Lesson 27, we learn how to find the equation of tangent lines and uh, learn what higher order derivatives are. We're just going to have a couple notations here. We've seen these already, but as you see here in this first thing, it says f prime of 7 means you want to find the value of the derivative when the value of x is 7. That's one way of showing the notation, and then below it, this one right here that I'm highlighting, this is dy dx evaluated at 4, means you want to find the value of the derivative when the x value is 4. So this little example here, we have y equals x squared minus 4x plus 3. We want to find the derivative when x is equal to 3. We do not plug in 3 first. First we find the derivative, and then we plug in 3. So we can write dy dx. We know how to find this derivative here. This is 2x minus 4. And then we can find dy dx evaluated at 3. And so this means we plug in 3. So 2 times 3, we put in 3 for x, minus 4. 6 minus 4 is 2. Now we're going to find the equation of tangent lines. And if you remember back from Algebra 1 and Algebra 2, to find the equation of a line, we either need 2 points or the slope and a point. And really that's what we're going to do here. We will have a slope and a point. So here's an example. It says find the equation of the the line. So line, y equals mx plus b, tangent to the graph of y equals x squared minus 4x when x equals 3. Well, we need the slope and we need a point. And once we know a slope and a point, we can plug it into slope-intercept form, and that will help us find b. So the slope, well, how do we find the slope of a line tangent to the curve? That's the derivative. We actually saw this function already. So dy dx, so we're finding the derivative of this is 2x minus 4. Well, that's the derivative at any point on the curve, but we specifically want when x equals 3. So we, again, just like the example above, we already did this when x equals 3. Plug in 3. 2 times 3 minus 4 is 2. So the slope of the tangent line is 2. So now we know the slope. Now we need a point that it goes through. Well, we know x equals 3. So if x equals 3, what's the y value? Well, we put x in to help us find the y value. And we put it into the original function we're going to find the y value when x is equal to 3. So we have 2 squared minus 4 times 2 plus 3. This is 4 minus 8 plus 3. 4 minus 8 is negative 4 plus 3 is negative 1, so y equals negative 1. So we know the point that it goes through is 3, negative 1. And now the equation, so again, this is back to Algebra 1. Sorry for that writing. Y equals mx plus b. We're going to plug in our slope, which is 2. We're going to plug in our x value and our y value, or x value and our y value, and that will help us find b. So we can subtract 6 from both sides, and we get b is negative 7, and so the equation of the line is y equals the slope 2x minus 7. So there's the equation of the tangent line to this parabola right here when x equals 3. Find the equation of the line tangent to y equals sine x. when x is pi over 6? Well, in order to find the equation of a line, it's going to be y equals mx plus b, so we're going to need the slope of the line. Well, to find slope, we use the derivative, because that's the slope of the tangent line to a curve at any point on the curve, and we learned that the derivative of sine of x is cosine of x. Well, we want at a specific point. So we want dy dx when x is equal to pi over 6. That's cosine of pi over 6, which we know is root 3 over 2. So the slope of our line is root 3 over 2. We also need to find the point that it goes through. Well, the point, we know x is pi over 6, so we want to find what the y value is. So sine of the x value, and the sine of pi over 6 is half. And now we can do the equation. So this, our point, I should write, is pi over 6, 1/2. So our equation is y equals mx plus b. We will plug in our slope, which is root 3 over 2. We'll plug in our x value and our y value. Now this one's going to look a little bit strange just because it's got a root and a pi in it, but it still works. So we have 1/2 equals root 3, actually pi times root 3 over 12 plus b. And we will subtract that from both sides. Going into our other question here, and we get that b, let's just write this way, equals 1/2 minus pi times root 3 over 12. And then we have to plug it in. So our final answer is, our equation is y equals m, which is root 3 over 2, x plus b. B is this 1/2 minus pi root 3 over 12. And so what that should look like is, you don't have to draw this part, but here's the sine function. Pi over 6 is about right here. So we're finding the equation of this tangent line right there. So the slope would be root 3 over 2, which is about 1.7 over 2. And the y-intercept is, we could figure out what that was equal to in a decimal form, and we might get a better feel for that where it crosses the y-axis. All right, find the equation of a line tangent to y equals sine of x when x equals 1. Well, the slope, we just did sine, so the derivative of sine of x is cosine of x, evaluated when x is 1. It's just cosine of 1. Now this refers to radians, so we're actually going to pull up the calculator and get this value. So we need to be in radians, and we can do cosine of 1, 0.5403. 0.5403 is our slope. We can find the point that this goes through. The point is y equals sine of 1 radian. So now we want to do sine of 1, 0.8415, 0.8415. 0.8415. And so the point is x is 1, y is 0.8415. And then let's separate this. Our equation will be y equals mx plus b. Put in our slope, 0.5403. Our x value is just 1 plus b, and then our y value was 0.8415. Well, we can subtract 0.5403 from both sides, because if you multiply that, it is 1.5403. And we get b, b equals let's see, 7.003, just about 0.3. And so our equation is y equals m, our slope from before, 0.5403 x plus 0.3007. And that is the equation of the tangent line at x equals 1 radian.